All right, so we have Team A part two, right? So it's the second video for the second assignment. So last time we basically left off on how to make this model, how to start abstracting it, very similar to Team B, but a little bit more, what's the word, subscribable, I suppose. In our case, probably we have a lot of different designs. Some of us maybe even curvilinear, maybe some of us rectilinear. But I wanted to go over some of the unique things that we could still do, because for Team A, really the goal here, guys, is to make it as real as possible. And what I mean by that is not every single brick, but we start to get a layer of realness, right? So we start to move outside of massing, which is always great for abstract design. But eventually, I think a large question in architecture, especially in architecture school, is like, well, how does that turn into a building, right? Or how do I make that look a little bit more real? To give you a total cop-out answer, we don't most of the time, especially in the first 2 years, or even arguably in the first 4 years of architecture. We're not making buildings, we're making art, we're making experiences, we're designing space, right? And don't get me wrong, that is a paradox in itself. But interesting enough, what we can do is we draw it, right? So I do want to go over some ways to obviously start turning this into a floor plan, potentially something that I can print out, even start to redline, or you could redline yourself or your professor, and then actually implicate some of those changes in a more detailed way, such as the digital model itself. I think some students, they get a little hung up, they get a little OCD like I did. In fact, I had this one student where she completely ignored the design of the building and started working on the kitchen, started getting all the appliances, started getting all these different things involved, which is great, but that's almost too real, right? Almost way too real, especially if I never even have an interior perspective. Then it was lost time, right, to say the very least. So at least in some explaining, I do want to go over some foundation stuff, some wall stuff, and then I want to show you how to cut it up a little bit. And I do want to end it probably with the best way to send that STL file, because I did skip out a lot of things that are somewhat a little bit more advanced. So last time we ended up with basically this, we'll just squint a little and pretend that this is my art supply building. And to be fair, after looking at it last night, I was typing on some things and going area, and it will give you these areas, right? So for instance, I have 3,024 square feet. That's too much, right, in some cases. So I think you're going to realize, wait a minute, we need to find these things. And hopefully some of you guys know that already, like your intuition is like, wait, can I just type area on this? I hope that is the case, or perimeter, because it is a pretty unique software, but I never really get to dive into some of these things. But for instance, I don't know how many of you guys, the first thing that you do in a studio project is program it, right? You find out the square footage, you maybe even make some box diagrams or even cut it out in a little box, and that's really great. But the great news is actually we can just draw random squares, random circles, random shapes, and actually get those areas relatively easily. For instance, I can't tell you how many times, a shape that's unique, like a pentagon. Where'd it go? Come back. I could have swore I drew it. Let's try that again. There we go. Something like this, when I type in area, it is really nice to be able to go, wow, that's 4,344 square feet. Wow, that's too big, right? Or I need to divide this. So I don't know who needs to hear that, but it just kind of reminded me. But for the sake of today, I'm just going to really make a foundation for this area. So for instance, I'm thinking it's actually maybe like a 2-part foundation, maybe not just one whole solid one, but I don't know. We'll fake it till we make it today. Again, the design is improv. Clearly, I don't plan everything out. Sometimes I just kind of go for it. But in my case, I have my topography locked and I have my object going. I think I started kind of topography or a foundation earlier in the video last time, so I want to give that a little bit more justice. And in my case, I might just need to trace it first, right? Maybe I do want something kind of a unique shape at the bottom. And I'm thinking, some sort of foundation. Maybe it actually goes to one of these streets. In my case, I think it's actually over here. But let's say it was going to that parking lot per se. I'm holding shift so that I know it remains flat. Hey, there's the piece I was looking for. Oh, and you can edit undo when you're drawing shapes, by the way. So perhaps this is my foundation. Hopefully it's not locking on anything, but if it does, I could definitely make 2D. So in my case, faking it till I make it. Let's go with a solid foundation for today. Obviously we could just do this twice if we needed 2 foundations. Looks like I'm locking onto stuff, which is okay. I'm going to basically take that element and flatten it, because I got a feeling, yeah, it's a little wonky. Although, my goodness, what an interesting idea of a shape right there. I don't know, I'm constantly inspired by these things. But let's continue, make 2D, and apply. In my case, it probably went way over here. Yep. And let's get that actually a little out of the way. All right. So now that we got this flat shape, I essentially want to turn it into some sort of grid. I mean, the lack of a better word, let's face it, when we do construction, there's lots of different ways, and I would say it's fair to go through your architecture handbook if you need one. I've got one in my Graphics 2 studio right now, but you need to pick a system, right? It's either steel and beam, very similar to to Team B, right? Doing steel and basically a frame model, or some concrete, right? Some sort of precast shear wall thickness, it's got to be, or maybe even a blend of the two. But you need to make some of those decisions, and again, we don't have to be engineers anytime soon. You can fake it till you make it, and I'll help you at least dial in the sizes if you need to. But in my case, let's say I was going with some sort of waffle slab, or some sort of solid structure that I really want it to be just more than an extruded box. So for instance, don't get me wrong, it's okay to kind of start with this, extrude, and go with 12 inches, right? It's okay to start there, but in some cases we want to go a little bit further than that, right? I mean, we want to make some structure. So in my case, one of the best ways to do it is actually to start off with that structure. So for instance, we'll take a 4x4, so 4 by 4 feet. We'll zoom on that to a little bit better. And essentially what I'm doing is making my waffle grid first, and then I'm going to apply that to the circle, right? Or sorry, this unique shape, because we can. In my case, there's a couple things we can do. So I'll take this one, I usually offset it, and I get the thickness of essentially those middle beams. So in my case, I want them to be about 6 inches, so I'm going to go half them and do 3 inches. And go in 3, and I'm basically going to raise that. Maybe the thickness of my floor. So I'm going to move it, get a separate view on that one, and I'll just raise it up 12 inches. Hold shift and keep it together. Now from here, pretty simple. I can essentially extrude this box. I mean, there's a couple things I can do. I can get kind of that angle. I kind of like that angle, so I kind of want to keep it. In my case, I could loft this. We can get that piece. And now I basically have something that I can subtract with, right? So for instance, we can cap it too. And we can get a regular box. In my case, I already have the dimensions, so I'll just take those. And we'll go, I don't know, 18 inches. Maybe the entire floor thickness is 18 inches. And then essentially subtract things, right? So I can, of course, take this one. Sometimes if it's on the same face, you'll notice it won't actually cut it, but in this case, I think it might, just because, I don't know, I'm feeling lucky. So in my case, Boolean split, piece, and enter. In my case, we'll take that extrusion out. Ooh. And take that leftover piece. Now in my case, it didn't actually work, so we'll move it slightly ever so out, boop, like that, and say Boolean difference or Boolean split. Honestly, I think both work fine, but there we go. It was the same face, so that's what was giving us an issue. But I essentially want this piece, that way I can kind of take this guy out and essentially be left over with, kind of a structure. Let me get a better view of that so you can kind of see what's going on. There we go. So I essentially have this overall structure, right? That, well, if I mirror it, I have 2 bays of that structure. Let's mirror it again. So don't get me wrong, we do have to make some decisions first, like, oh, I want a waffle slab. All right. Well, now I got something that definitely appears like a waffle slab. You know what I'm saying? Like, almost like we're looking at this building if you were, honestly. Right, and we could start to develop columns at these points. I could actually put some more thickness here. So for instance, it's kind of looking real waffly. So for instance, I could do something like this, where we make a box and subtract from it. Box. When in doubt, man, box is probably still the most used tool, mostly because we make a lot of boxes. So something like this, and basically chop that piece off, right? So I could put these four together even. I don't necessarily have to, but I could. So Boolean split. Take that one. 1, 2, 3, 4. Enter. We'll basically take that piece off. So that little small one, right? Just to kind of show you what that did. And don't get me wrong, I guess I would call this the sculpting method, right? In my case, I'd want to make sure that I got the entire piece off. So let's try that again. We'll make it a little extra big. That way we know that it gets the extents. Oop, wrong one. Let's take that out. And take that out a little bit too. Make sure we cut all our boxes. Boolean split. Let's try that again. Oh man, I got a lot going on in there. Let's get rid of that first. My bad, my bad. So we already have that chopped one, which is great, but I really want to apply it to all of them. So there we go. Yeah, we're good. Boolean split. Oh wait, that's the bad one. Here, let's try again. Mirror. And you may notice when I'm doing the mirror, I'm selecting essentially the same mirror points, right? So locking on, using my O snap, just in case you're wondering, it kind of looks like magic. I definitely remember thinking that it looked like magic. And let's try that again. Don't worry, it all makes sense soon. Like, man, why is he working on this like waffle thing going on? So I'm gonna chop that up a little bit. And Boolean split. We'll just take all of it. Nice. All right, now that we got our pieces, and in my case, it's like, hey, which one do you want? This one. We basically have much more like a waffle slab, right? We got that little chunk off, if you will. And now we can have fun. Because now I have this modular piece that I essentially want to put to this. Now, there's a couple of ways to do it. There's a little bit more automated ways to do it, to be fair. I want to show at least the manual method. So in my case, I'm just going to Boolean union this, because I kind of want to treat that as my solid piece, right? And array it. So in my case, I don't want to go big or go home, so I basically want enough so that I can essentially just trim it off. So I don't know, I'll go with 24 in this way, 24 in that way, and only 1 in the Z direction. I don't want to like increase it this way, I just want to kind of spread it out in the X and Y. So in my case, it'll say, where's the base point? And in my case, I could really get big with this, right? And we'll just lock on to that other side. Looks pretty good. It definitely covers that space. So I'll hit enter. Sweet. But now I have an entire waffle grid, right? All that structure ever so easily, right? And we can use this tool to now apply it to this guy, right? So I'll basically hover over, and I can't tell you how many times I've been in studio and I've even asked students this, where's your grid, right? Have you heard this before? How do you come up with your grid? Sometimes you have to start with a very simple grid, like an X and a Y. Most buildings, let's face it, in America, and especially American culture, are very orthogonal. In fact, this is actually to reduce costs and stress of, well, different building loads, right? As soon as you start to apply curves or have interesting triangles, you do have to do different calculations, and that is for the engineer. But let's live a little, let's dream. In terms of grids, you could do a triangular grid, you can do a hexagonal grid, you can do all kinds of grid, rectilinear. I mean, the world's your oyster. Just keep in mind, somebody's got to build it one day. So if you can't build it in this program, chances are somebody can't build it in real life too. I mean, that's a pretty simple and hard to live by rule sometimes, especially when you can do just about anything you want in this computer program. So from here, I'll basically take this flat piece, and it's looking a little sloped, no? Is that just me? Let's flatten it back out. Worst case scenario, I can just extrude it again, but maybe this one's not flat. Oh, would you look at that? I accidentally rotated it at one point, I guess. Let's make that flat again. Now it is going to be slightly off, but for this, you know, doesn't make a huge difference. But yeah, I guess I accidentally moved that. Not sure. We'll take that again, and we'll basically put this over. In fact, it might be okay to even just take it as, you know, I don't have to extrude anything. In fact, I could chop it up. But now I can see my grid, and I could even start to, you know, line up certain grid points, right? And don't get me wrong, we're going to need some sort of like trim for this, so let's do it. But as you can see, I have to have a plan first. I have to come up with something first to even apply now what I would call the standards of architecture now to sometimes my design. Man, what did I do with that curve? Come back. What could I do? The filter tool, right? Be like, I only want curves. Nice, right? So we can get that out. And basically just wire cut this. Man, I did it again. Is that not flat? Is this whole board not flat? Is that what it is? I don't know, I did something. You guys see that?
Yeah, it kind of looks like it's at an angle.
It looks like it's at an angle.
But it's so weird.
However, this is pretty advanced, but there is a way to fix it. I'm not gonna lie, we have to draw a flat rectangle. So we need to make sure that one's flat, because something's off. Okay, that one's flat. We could take this entire piece. Oop, as long as you don't have the filter on. Let's fix our problems before we continue. What do we do? Well, there's this thing called 3D Orient. So I have a feeling it's actually this piece. I should probably keep this for the sake of diagramming, but let's get rid of some of the things I accidentally copied. Check this out. We'll take the entire thing. Now this is where grouping definitely comes in mind. All right, so I'll group that first. I don't really want to put it together, I just need it to all move at once. So in my case, there's this thing called Orient, but it's called Orient by 3 points. So essentially how this works is I set those 3 points for this orientation. This can become really useful, but it is kind of advanced. Basically, it asks for those 3 points of the original object. So I want to choose something that is the flat face. So the top point here, the top point here, and it doesn't really matter which top point, but it's got to be this top point right there. And a third top point. So in my case, it's essentially making a triangle. From there, it's going, okay, now where do you want those 3 points? Well, pick a flat area. So here, here, and see how you can kind of angle it, and here. Now it is perfectly flat with that line. Pretty useful. Back to what we were doing though. So we're still making this foundation. We basically align those things up, and now we're just kind of chopping them out. So in my case, wire cut. Now this is what I mean by wire cutting a group. Actually, you know, I haven't tested in a long time. Let's try it. Yeah, I didn't think so. So obviously we got to ungroup it first. We may even have to Boolean union it first. Let's do that. Put it together. Oh man, it's freaking out. It's like, dude, you just asked me to put thousands of pieces together. How dare you? In your screen recording? How dare you? Anyway, we'll give it a second. I don't know who needs to hear this, but if you got a Mac and it's spinning, do not click. Just let it load, right? In fact, you may even want to do something else. What is nice about the Mac though is if you do hit escape a couple times, it will go back to normal, right? Which is nice because a Windows would just freak out at that point. Same thing, rule for Windows, don't hit escape if you notice it's loading or it turns gray. Leave it for about 15 minutes, worst case scenario, it'll come right back, right? You can hit escape a couple times too, but let's face it, that usually starts to make it freeze too. In my case, I'm going to reduce just because I guess that's a lot for my computer right now. So I'm going to get rid of obviously the ones that I'm not using, right? Or going to even cut through. So in my case, I should really change the colors of those. I could barely see it though. There it is. But yeah, let's reduce just to save my computer a little bit. There we go. Maybe that'll be easier for it. We'll Boolean union. Let's try again. Please don't freak out. Please don't freak out. Nice. Actually worked. So yeah, the reducing actually helped a little bit. But now we got that waffle slab, the standards, if you will, construction standards, and now applying our design to it. So, wire cut. Cut that guy right out. Voila. We'll get rid of, obviously, this piece. And now we have something that looks somewhat architectural. And now that if I start making my design and starting to get, a 1-point perspective or, even outside in, we do something that starts to look arguably architectural. The next thing that we could do is give it some sort of frame, right? Some sort of boundary. So in my case, I'd probably want to match this profile. And if you can't get the profile, maybe this is the next thing that I really get into is clipping plane. I know I've shown it before, but I probably haven't really shown its use yet. So we have our clipping plane, and man, that thing is still slightly turned. I don't know what that's going on there. Oh, maybe. Nope, it really is slightly turned. Either that or I'm accidentally making everything slightly turned. So I'm gonna reset my C-plane, because maybe it's just my C-plane that's slightly off and I keep drawing stuff that's slightly off. Yeah, I think that might be the case. Does it look? It looks tilted to me again. Is that just me? I guess there's one way to find out. Man. Yeah, it's totally tilted. Dang. I think it was my C-plane. But anyway, we'll move on. However, now you know what to do when you run into that case. But what's also really nice about this is now when I make a cut section, I have all those elements. I don't have to draw all these little profiles and essentially, well, even if my professor changes my section, he goes, well, no, I want you to cut it over here. Well, great. I still have that as well. But what's great about this is we can take this piece and we can just draw on top of it too by tracing it. But let's zoom in that a little better. There we go. But of course we can make 2D. In my case, I want a very specific view. Obviously I don't want this view because it's gonna warp the way that looks, but maybe the back view or the right view would be pretty nice. Now I want to make sure which view I'm looking at, and to be fair, it looks like, man, it is wildly off. I almost want to 3D orient it again, but it seems like this was actually wrong, so let's try another rectangle. Let's just go for it again. It's so annoying to my brain that I have to fix it. But you may run into the same problem, so let's at least cover how to fix it. We'll take that same shape, 3D orient, or orient is usually what I put in first. And then there's two options, orient 3 point and orient 4. We have to choose familiar points, so again, it just has to be 3 points. 1, 2, and those 3 points have to be within the same plane, right? So I chose those, and my last one will be right over here, right? All on the same plane. But again, lock on to a device. Not too shabby. Looks like I flipped it upside down, but hopefully it's perfectly flat now. Please? Yes, that is looking good. All right, so we fixed it. It was definitely my C-plane and it was slightly off, right? Good to know. And especially because you might run into the same thing. Anyway, back to what I was doing. Let's give this thing a border and let's apply it to our model, right? I mean, why not? I know this is pretty much a hodgepodge of design, but I also want to cover a couple things, and I didn't plan to run into this many errors. But let's get that back into our spots. Pretty easy. I can find a point on here. Now this is where near comes in handy, right? Not very often, I will say. But with near, you can get these like, oh, I just want near it, right? I just want it pretty dang close, right? Unfortunately, unless I put like a measurement, and that's good enough for government work, as they say, right? I mean, for this curvilinear item, I can only get that so close. I'm sure there's ways to lock in, but I don't know them right now. But in my case, let's say I had a unique profile. you know, something you guys probably are familiar with. You know, some sort of edge. So we'll just go with like a simple triangle. Oh wait, no, let's actually get that exact profile. My bad. That's what I was doing. Clipping plane. Sorry, my bad. There we go. Now I'm seeing the right thing here. There we go. But let's get that view. So I'll take that item. We'll go to the view that we want to create the profile from. That one looks pretty good. There's that profile I want, right? Because I want to match that angle, and I might have done something unique. I didn't really do anything unique in this case, but I might in my studio. So make 2D. And I do apologize. I can understand that the, what do you call it? The Team A tutorials are a little more dense, if you will, in terms of waiting, which is, you know, why you can totally pause and skip this part if it seems a little too boring or unuseful. But in my case, obviously I don't want to copy that one. I'd rather copy this one or just trace on it, right? So in my case, I'll trace it. And I just really want to maintain that angle, so I'm just going to take this piece right there, right here, and just ballpark it. That's looking pretty sweet. That'll be my profile, essentially, for this sweep. So I'll take that. We'll move it on over. I'll get rid of my clipping plane. And this is why you should layer things, right? Otherwise, you might have not great eyesight like that, right? In my case, I do want to make sure it's perpendicular and basically sweep it all around this edge. In my case, I also want to make sure that it's perpendicular to this rail. So in my case, gotta turn it a little bit. Ooh, wrong way. That's okay. Eventually I'll get there. Also probably a good use of near on this curve, right? But we want to make it as perpendicular as possible. So again, near, man, we're using a lot of nears today. But yeah, let's get that profile. So sweep, sweep one, rail, profile, enter, direction, doesn't really matter in this case. Sweet. Take that piece and bring it on down. Ah, now we got a nice little concrete border. You guys see that? So again, I know it almost seems like there's a lot of work for the steps, but keep in mind, this is after we've talked to our professor. This is after we've already discussed the design. We've changed some major things, like maybe where the rooms go or how they relate to stuff, but now it's in post-production mode. Now it's almost like we need to build a final model, very similar to Team B, right? You almost had to make that model first digitally to the realest of your ability, delete some things here, delete some things there. Then we use that to, of course, as our kind of final quote-unquote model. But in our case, that's looking pretty good. So I'm going to put those together. Boolean union. It's going to freak out. Please don't freak out. Nice. However, now once it's in render mode, it starts to look like a pretty unique construction, right? Definitely a waffle concrete structure. And arguably what's even nicer is I can still chop away from this. So for instance, let's say I wanted, you know, for God's sakes, wanted something like this, right? And maybe I want my design to kind of get influenced by that. So let's take a look. Whee! But now it's starting to look a little bit more architectural. Maybe I have this huge shading device, I'm not sure. Keep in mind, the design is not what I want you to copy, right? Just the techniques. But in my case, that might be something I'm going for in studio. Maybe I even want to actually start to put that on top, right? Fake it till I make it, right? Kind of implying that, well, that concrete is on top of structure. Maybe we have to elongate some of that structure. Shoot, maybe I even have to cap it. Oh, that's right. This was Matt's model. Dang it, Matt. Just playing. In my case, I'd want to take that face. Hopefully I can find it. It's kind of small right now. Let's see if we can zoom in without going too far. Doesn't look like it. We'll take that piece instead. Oh, they're separate pieces. Boolean union. Anyway, you might run into the exact same things, right? Let's get that a little bit better. That's what I get for working in Revit last night. All my mind is like still stuck on Revit. Got that one, got that one. There we go. cap, Boolean union. There we go. So we turned it basically into a solid piece because it was all separated. In my case though, I don't want to select anything, so boop. And I probably shouldn't do this in rendered mode, but trying to get that face, but it won't select it. It's too small, or at least too small for the cursor. What can we do? Got it. Try again. And why not? There we go. There we go. Give me the face. Well, I can get every single edge imaginable. Oh, there it was. Got it. But now I got other things selected. That's okay. I'll hold that one and push it out. Right? Maybe I need some more structure. Again, I'm holding Shift and Command on there. Giving myself some more structure. Starting to make it a lot more believable. And let's face it, a heck of a cooler 3D print, right? And definitely better for renderings, right? Now, obviously, these are for my D3 and D4 folks, right? And some, right? You really won't get too crazy like this until, honestly, D5, D6, D7, and D8, your third and fourth year. But hey, why not prepare you now, right? However, it's starting to look pretty unique. Definitely architectural. I'd probably want to do that to a couple of these. And to be fair, the easier way of what I just did is probably actually doing it the old school way. Usually I just take the whole dang thing, make it bigger. I just chop it off. I mean, there's two ways to, I hate to use the same, but there's more ways to skin a cat, right, than just one, is how the old saying goes. So, I mean, don't get me wrong, you can fix things like I just did, but you can definitely see that some things take longer than others. They just take more clicks. I could simply take that and, of course, chop it off again. In my case, though, maybe I use it for my foundation as well. So in my case, lost myself. Also, remember to turn near right back off. It can be detrimental. But yeah, maybe I want some sort of foundation. Slightly put that up a little bit. Not bad. Looks like I added too many. Oops. The heck is this? Oh, that's my topography. My bad. So maybe I want that to be a little bit over. Bake it till I make it. Make that so you guys can see it better. There's the one I'm looking for. There we go. A little bit thicker. All right. Now we're getting somewhere. Now we got maybe topography, and maybe we walk up onto this building. Now, obviously, I've done this with a very complex shape, and I did that kind of on purpose because, well, it gets easier, right? As soon as it's just squares, or imagine taking that grid and just kind of matching my building. Maybe I have a unique kind of building set, if you will, like for instance, what I have right now. So it's almost like we have a mass up here, we have a mass down there. I could do the same thing with that 4x4 grid. Does that make sense, guys? It's almost like I want to make the grid essentially after I get done with my abstraction, right? I want to start to realize it, right, for the lack of a better term. But it's definitely starting to become something. Definitely starting to be a little bit more architectural. But the next thing I would want to express is I got to make a plan of this. Let's face it, making a digital model is hard in itself, just kind of imagine it out of thin air. So sometimes what we have to do is go to our professor, we have to do a clipping plane, and we got to print it out, right? We got to see what the floor plan looks like and start drawing these elements. So for instance, right now this one's just a box, right? And I might want a room. We did do kind of the room idea a little bit last time, and you guys kind of saw what we did there. And you also saw how hard it was, how difficult it was, even for myself, experienced, to manipulate sometimes this model. And arguably, we can use the tools and the tools that we've actually already learned at San Antonio College a little bit more effectively. So we can take that piece, go to our top view. Now, this is where you want to make sure your clipping plane and properties is also on that top view. That way it actually starts to change these things. You start to see those things. I'll take everything, make 2D, and essentially produce a template, right, for my floor plan. As you can see, it didn't get jack, right? Probably because stuff is getting covered up. It got one box, and arguably it got that door stuff that I worked on last time. But what gives, right? I may have to even reduce some of my elements, right? So in my case, I'm gonna hold shift, or sorry, hold command, and I want this piece, right? I want to start formulating these rooms or programming them, for the lack of a better term. Make 2D. Apply. And let's make sure it got that. Man, I may need to actually have my hidden lines. I wonder if I've got something hidden. I might. No, doesn't look hidden. But clearly you can also see we could do a second floor, a third floor. And there's definitely, you know, a lot of use in that. But not if it's not working. Let's see what's going on. Run into some issues today. That's okay. We all run into issues with computers. Nobody's perfect, not even myself. I want to clean up a little bit. Sometimes it helps me think better. But in my case, maybe let's hide this real quick. I'm not sure if it's getting hidden in some way or if I'm accidentally looking at the bottom. Let's find out though. We'll take that piece, maybe uncheck my clipping plane. That might be giving it an issue. I'm going to go ahead and give us hidden lines just in case it is there. I'm going to go ahead and do some tangent edges. Clipping plane intersections. Yeah, that's probably important. So, yeah. Let's do that. And voila. Right, looking much more formidable. But now I've accidentally hidden those pieces, so let's show. And let's try that again. Alright, we got everything, Let's try it one more time. Make 2D. Make sure clipping plane intersections apparently is checked. Can't remember if that was always an option. And there we go. That was definitely it. But now we have our hidden lines, so I do apologize because that's a mess, right? But clearly something that I can use as a template to now start drawing. So for instance, don't get me wrong, sometimes we use that massing model just as a massing model so that we can make 2D. We can make it even more detailed and use those detailed curves to make an even stronger model. Am I making sense here? It's a process, and I know even in studio it's almost like taboo. You're like, oh my god, I gotta do something again. I gotta do it again. I gotta do it again. That is true of studio. And welcome to architecture, because doing it again usually leads to better results, better design, more thinking about certain complex situations. Eventually this will be, you know, 120,000 square foot university, and you definitely want to make sure you know every building and every part that goes together. In fact, some would argue that is what makes a good architect. Anyway, in our case, like I'm saying, well, now we can use this piece. Now we can use this piece. And I'd probably actually get rid of all my my hidden lines, but what would be nice is now I can show the structure of my drawing. But in my case, I'm going to join these. I'm going to take that piece. Whoa, took the wrong one. We'll take that one and that one, join it. I don't know if that'll join. Yeah, join. Offset. Maybe I want 6-inch walls. All right, we got 6-inch walls. Maybe I want stone on that wall. Anybody know what we offset for stone? It gets weird, 5.5 inches. Enter. That would be our stone. Maybe I only want stone on this edge, so I'm going to draw a line. And this is definitely probably where near comes in handy. Take that piece. I can mirror it. Maybe I want the same thing on the other side. Enter. I want my midpoint. Oh, see, that's where near is dangerous, when you actually need the others. Midpoint. Hold shift. I'm going to mirror that. Now I want just kind of this like little band of stone, so I'm going to trim it. Cut that one off. Oh, cut the other side off. Perfect. But now I have this shape that I need in order to produce that little thing in 3D. So for instance, hear me out. We'll get this piece, we'll get that piece. Man, I swear, my dad always calls at the wrong time. Like, doesn't matter. I'm always in the middle of something. Maybe I'm just always in the middle of something. I don't know. But for instance, now I can take this piece and now go back and make it 3D. So for instance, let's do a little bit more detail there. My dad was throwing me off. I'll make a door, right? I mean, quite literally draw it, guys. And let's get the hidden lines out of there. That is getting a little confusing. I think even to see it. Turn off all make 2Ds. No, just kidding. We need some of them. But let's turn off our tangents, our clipping, and anything that is hidden. There we go. All that hidden stuff, take it off. But it looks like I turned off too much. No! Turn this back on. There we go. So yeah, I guess that is a little bit different. But for stuff like this, you're like, man, I don't want the walls to actually do that. In fact, I want this to be two different rooms, or, you know, maybe not. In my case, you know, fake it till I make it. Obviously, this is for tutorial. But let's say I wanted to actually put those together. I'm not going to spend my time like trying to Boolean difference these two rooms and trying to get a little space in there. I'm just going to draw it. Because, well, now I have a floor plan for my studio. And now I even have a template to, again, make version number 2. I mean, how many study models have you made for class 1? I know I've made a couple for certain projects where, especially Boveslav's project, where you make multiple study models, right? Honestly, we're doing the exact same thing is what I'm trying to say. But there's some unique two-dimensional tools that we can use. For instance, we can even just draw that again, right? So for instance, we can use the template as a template. So for instance, that piece. And what's great, I already have it drawn, right? So now I have that edge that I need. In my case, I was working on the door, so let's offset that. That's a 3-foot door, sweet. 3-foot door, trim, trim. Oh, got rid of too much. Take the whole piece, trim. But again, what's nice is now I have a two-dimensional drawing and potentially what I need to make my next model. Not that it's required, right? But you may either need to struggle with, you know, that model. Let's make the door, right? Why not? I think we did the 3-dimensional door last time, didn't we? 1.5 and 3 foot. Typical door. We can rotate it a little bit. Take that point, take the other side. Okay. And move that to our center. Starting to look like a door. Arc. We can, actually there's several ways to make an arc, but I believe if you do that, that's not the right way. Let's go with that center point and center point. There it is. Door, right? What's even better is I can group that. And we have all the doors, right? Now we can just copy that. We can put it somewhere else. Maybe I need a door over here. Oh, there's that door, right? And it didn't come in too great. So I'm gonna go ahead and put it there. Move it. And arguably, as you can see, some of my mess ups of trying to model it, right, if you will. Yeah, to say the least. So in my case, I may want to redraw that. Get a line in there. Offset 3 feet. Don't get me wrong, eventually you have a lot of practice with this. We can trim those things to make a door. I suppose the next thing we can do is make that second model, right? So for instance, if I wanted the stone on the outside and just regular walls, well, I could take those things. Now they do need to be closed. So I'll take all of these pieces. All right. Oh no. Oh, maybe we can cap that one. There we go. And maybe there's a line in there. Oh, we got a line in there. Let's trim it first. Boop. And yes, this is why we go to school for 8 years, right? Because we have to know a lot of stuff. Looking pretty good. Looking pretty good. I'm gonna go ahead and join that. Let's try again. Of course, things will join as long as they're able to. So for instance, that random one over there didn't join. Oh, there's a piece I need. And there's a piece I need. There's the other piece I need. Oh, we don't need that one anymore. There's the other piece I need. So let's take a look at it. And again, now we have our revised floor plan, maybe that we met with our studio. And now I can go, well, actually my studio professor said instead of that 10 feet, go ahead and only do 8, right? Okay, so we're gonna go with 8. Oh, and that stone wall, let's make it kind of short, you know, maybe only 4 feet. So again, we already have the next model, if you will. Same thing here. It's basically going, hey, are you sure you want to do this? One of them looks a little off, or undesirable results. Sometimes I'll do a closed curve because usually that's kind of trying to tell you that, hey, yeah, I had one little slight error in there, so it had to add one. Extrude. Keep in mind those are kind of important because if you're trying to cap this or trying to keep it solid, sometimes it won't stay solid. Another thing that's nice about this is, well, if I want a half wall, I can align to these things. If I want a full wall, I can align to these things. So again, kind of nice about those. But now we can cap them. Oh, it looks like I needed to close that curve too. Obviously the closed curve one gave us a solid form, but check out what that accidental error did to this wall. And I can't tell you enough, I see this so much in studio. Or we see the wall, but we don't actually have the thickness of the wall. Now that would probably be okay in studio, but for this, we're gonna 3D print it. And we know that we need a closed object. So that ain't gonna work, right? I may need to go back or simply take that curve again and close curve before I extrude it. And just try again. Let's go 8 feet. And there it is, solid. Right. Now technically I have 2 in there, so I would want to get rid of the one that's not good. That poly surface. So yeah. Now there's the one that I'd want to 3D print, which brings me back to my piece. So again, I know kind of a short tutorial, but we have about 10 minutes left, so I wanted to get into a little bit of that 3D printing. Sorry for all the errors, but just to kind of recap some of the modeling stuff, we went over definitely some structural stuff, how we can Boolean difference, we can make a waffle slab. We've also shown how we can slightly start to integrate pier and beam structure with that concrete shear wall structure. But the last thing that we wanted to basically cover was essentially making actually a correct mesh, right? So yesterday I forgot to even show you how to make a corrected mesh, but let's say for instance I was about to 3D print this. Now these aren't actually touching, so I can't really 3D print this. In my case, maybe the best thing to use is maybe our previous model. So let's maybe do that real quick. But I'm gonna have to put that all together. We'll use this one, not a big deal. Let's give it some sort of box, just to play like we have a foundation, right? Let's pretend for a second. There we go. Now I can put something together and make a formidable mesh. So in my case, Boolean union, just like yesterday how I had to put everything together to make it one color. I need one solid object. As you guys know, we'll turn it into a mesh. I kind of wanted to show you what more polygons versus that does, so let's go with more polygons today. And as you can see, it really gets every single triangle in the world. But there's that mesh we need. However, the next step that we can actually do in order to check, sorry Gavin, was that a question?
I was just gonna say, like, the more would that make for like a better 3D print or no?
It does technically make it larger, and like for instance right now we have only 90-degree angles. We don't really need more polygons.
Yeah.
In fact, it won't change the quality whatsoever, just the file size. However, if you're doing Shrek's face, you may want more polygons because there's a lot more curvilinear edges. You may want to get his ears just right. You see what I'm saying? Now it's not going to really like change the model or simplify it, but it's weird. It kind of does, especially in rendering, right? It depends. If you're a Pixar animator, yes, right? If you're usually doing an architectural rendering, it doesn't really apply because we use a lot of straight edges, right? To be completely honest with you. But it's a good question, for sure. It doesn't really matter though, in most cases. However, there is another tool called Mesh Repair. So if we go all the way down or just type in repair, Mesh Repair is a unique tool that Rhino has to tell you if it's a good or bad mesh, if it has holes, or really we start to get into the vocabulary of what a mesh is. Once we hit that, it brings up a little window and we can check that mesh and it goes, this is a bad mesh. What do you mean, it's bad? Well, basically it means there's a small opening somewhere. It could mean a multitude of things. Basically the way stuff works in a mesh is we have an outside of our surface and an inside of our surface. However, some of those surfaces can accidentally be flipped, which can basically lead to a machining error when you 3D print. Not to get really into the thick of it, But you can repair your mesh. We'll repair it, and we'll hit next. Now it'll actually show and start to indicate what is wrong with it. So for instance, it's relieving that open edge, right? It's still actually reading as an open edge, and it's quite revealing, right? Especially when we did the Boolean union, it was like, hey, I don't know what to do with this, and we have an opening. So in my case, sometimes I can actually close these things. So usually I check all these. Even though they say 0 right now, I'll still usually hit repair, repair again, until basically it's a good mesh. However, as you can see, it's not going to fix that piece. So we'll finish. We'll exit on that one. And I may have to try again on this one. For instance, I may want to fix this one first by capping it. Capping it may work. I don't know. I saw the cap work yesterday. I was amazed. But in my case, I may have to go for broke on this one and go, ooh, you know, I think it's really missing some faces there. I may just have to get the other one and make another one, right? Or I could sit here and get my 4 points. I've seen students do this, and I'm not gonna lie, I've definitely done this in the past. You know, broke for time, and I simply use my 4-point method, especially on something as simple as this. But as you can see, a lot more clicks. But using my points, it is technically possible. And I'm just locking right back onto those points. Now this is where it gets funny. Essentially making triangles. Oh, that one didn't work. As you can see, you're going to run into some pieces, right? In my case, we'll leave that piece to the very end. Really into the thick of it. It's almost like we're making the mesh for it, right? However, I'm not going to do this all day. We'll take essentially those pieces and join them, right? So if you join them, it will turn it into that solid surface again, but it won't magically do the rest of them, right? However, in my case, I would say just try modeling it again, right? So for instance, that piece, got to make sure it's closed. Or sorry, closed curve. And it's saying it's not even open. Type what? I'm looking for the word closed. Gavin was on it yesterday. Closed polycurve. Wonderful. So now that it is closed and I do extrude it, it should be okay. Closed curve, extrude, self-intersecting curves. Now that one's harder to avoid, but basically that means I need to trim something, right? So self-intersecting, right, is kind of the... So I might have to check it, and there it is, right? Get that guy out of here. But again, usually I actually just highlight it and check, especially depending on how complex the item is. A lot of troubleshooting today, honestly. I kind of like this video because, well, it's definitely true, right? It's very, very honest. This is exactly what you run into. That one does look a little weird. Let's see what it is now. What? Okay, valid curve and closed curve with 2 curve segments. That doesn't seem right. Well, let's find out. Oh, don't do that. Go back. Let's try that again. Extrude. No, it's still got one. So in those cases where it's just like really giving you a hard time, what I would do is make 2D, because it could be something that's just not flat. Check all your bases. Take that guy, bring it back. We'll move it again. Probably switch the layer up on that one, because now I don't know which one. Let's try extrude again. Nope, still got the message. What to do? Man, it still just brings up that error. Although it doesn't look like an error because it did extrude. It's got a little overhang somewhere. I'm thinking it's right there.
Right bottom.
What is that?
I guess you have some leftover on the right bottom.
There it is. I found it. It's overlapping on itself, and I couldn't tell because they were on the same line. I'm glad I found it, but as you can see, this is why these programs can be extremely annoying. So I'd want to trim this off or just delete this one. Just delete it, right? Especially if you hit F10, you can go into those point modes. Let's try it one last time. So we'll put that back. And I got a feeling we're gonna have some success. Extrude. Damn it! So there's probably multiple. Let's face it. Right side bottom part. Right over here. Oh, look at that. Almost looks like there's multiple in there. See, this is the dangers of near, by the way. Because you get this stuff when you do near.
Do you have near
Oh.
activated?
Yeah. Well, actually I misspoke. Looks like this one was okay. But as you can see, we'll have to troubleshoot sometimes. I'm gonna close curve again just in case for good measure. It was closed. So it's saying it's closed. I wanna try again. Man, just self-intersecting curves. It looks like I over.
That one right there.
What is what?
The thing that's on it.
Right here?
Yeah.
Nah, that won't affect it. Because it's just this curve. It's saying that there's one happening inside this
Oh,
curve.
is it the door?
I thought it was originally, but man, it's really giving me a hard time. And what stinks is it's showing that it's actually a closed curve. But sometimes I'll do this just to see if it reveals itself. You know what I mean? It must be so microscopically small, I can't even see it. Is it that right there? I don't know, something looks a little off about that. I don't know. However, worst case scenario, and this is definitely at the very end, right? Is you lock all this. Because, I mean, I wasn't going to just leave you hanging, right? But I did want to go through essentially everything before we do this part, because this probably sucks the most, is having to redraw something. But you can. Take a polyline. Luckily, our shape is relatively simple. But let's face it, in some cases, not always the case. But in our case, not too shabby. I'll run this one a little longer today, because you know what? We're showing the real stuff. What do you do when you can't do something? Something I really wish my professors would have showed me when it came to digital technology, because I mean, they show you the tutorials that were like super refined, super great, you know, everything worked out, but you never saw them run into problems, you know. I don't mind. I don't have to say face, because you can't see my face. Anyway. But we got this piece. Let's try it one more time. If this doesn't work, then I am just a terrible drawer. That's what I'm talking about. So when in doubt,
Right, sometimes it's
let's draw it
best
again.
to restart
It's
and
just
mess around.
it's just best to, you know what I mean?
Yeah.
Like, cause you'll spend,
I've done that.
gosh, 30 minutes. That's why I say, like, if you've given it 30 minutes, just draw it again, right? Because as you can see, we could have just done that again in 15 seconds, right? Let's go ahead and unlock, because I do want to get back to the one last thing I wanted to show you, just in case you can't fix an STL. Did I spell unlock wrong? Oh, caps lock, my bad. Now that guy's a problem. So we know how to fix it, but for the sake of conversation, let's show how to make our meshes again and how to perfect them. So let's say that was the mesh that I wanted to 3D print. Awesome. We'll take that mesh. And keep in mind, especially if it's a really simple shape, they can look the exact same. So excuse me, the triangle doesn't always come up. So sometimes you do have to type in what and go, hey, is this a valid mesh? That's a valid mesh. So actually mesh repair for this one, it should probably be okay now. So mesh repair, check mesh. This is a good mesh. All right, well that's good. It's a good mesh. That means it'll 3D print just fine. It has no errors and it's a completely closed and water sealed model. However, if it still was a bad mesh, what do? We can export it back to that STL file. And we'll call it just test file for today. Put it on the desktop so we can find it. Export. We'll go with binary. Actually, in this case, that is super small, but export. Oh, let's get out of full screen mode. Oops. There we go. I'll take that, and I put this on the Miro. So you may have noticed I do put a lot of very helpful links on the Miro, guys. But there's this one called Free Online STL Repair Tool. I can't tell you how many times I've run into certain models where I don't have the time to like do what I just did in troubleshoot, right? Sometimes we're pressed for time and we just need to, even though it keeps saying bad mesh, I need kind of a fail-safe. So there's a wonderful tool that if we click on it, it goes to Formware and we can upload this mesh, and it's going to use a lot of cool algorithms and stuff. I honestly don't know how it works. But we upload that file, we'll go to desktop, that test file. Now luckily this one's really small, so it should go pretty fast. And yes, you can donate if, you know, I've made a large donation in the past, so I feel like I've covered it. But as you can see, since it is free, I am 21 in line, 20th in line. It does go pretty quick, but sometimes that number is like 800 and you're like, holy crap, right? This is gonna take forever. But what's nice about this in Formware, there's other ones, by the way, that you do pay, right? But this is at least the best free one that I've ever found. Essentially it'll upload, it'll do some magic, and it'll give us a download. That STL download is the one that you'd want to send me to 3D print, right? Just so I can cover that. We'll let that load in the background. It might go pretty fast. So let's recap and be well on our way. So just to recap, this absolute troubleshooting mess, right? Obviously we started off with some modeling. Ooh, those are cool. Where do those come from? Oh, maybe those are the leftovers. Get out of here. We started off with that waffle pattern, basically using a 4x4. We talked a little bit about the differences between those. We also covered a little bit of the clipping plane, how we can constantly use the floor plan in the section to actually make better models, right? And we can actually just draw what we want them to look like in section in order to basically model those as well. We then also talked about extruding them again to make that model, and for the most part we went over mesh repair and of course a fail-safe called STL repair, right, by I believe Formware. Yes. So let's see how we are in that queue. Maybe we can see, we're 12th in line. However, there's nothing too exciting. It gives us a little download link right here and we can essentially download it. So any major questions for today, guys? Maybe something you wanted me to model that I didn't really quite cover? Seriously, write these down and bring them up because it'd be great to do it. Anyway, a lot of troubleshooting today, so now you know what to do when you run into those kinds of errors. When in doubt, spend 15 minutes on it, move on. Draw it again if you have to. It's not the end of the world. So we'll end it there for today.